If your cover or if your robot's top cover is like this or like this, you can easily add a button directly on the cover, similar to this one, or this one. However, if you have a plastic cover instead, you may add buttons by adding additional circuit boards on top of the robot, or you may use a breadboard. In this demo, we'll use a breadboard. We have 1, 2, 3, 4, 5 buttons. We will use the following pins. Pins number 7, 8, 11, 12, and 14 or A0. Those pins are currently unused. We will need longer jumper wires for this. So I'll be using female to male jumper wires. To ground. Wards. I will connect gray to pin 7. The next one, the purple one, will be connected to pin number 8. One, blue, will be connected to pin number 11. Green to pin number 12. And yellow, pin A0, or also known as digital pin number 14. cords, I'll connect blue, which is connected to ground, here. So this will make the entire row ground. I'm going to connect one side of every button to ground. This is ground. One side of every button is now connected to ground. I'm now going to connect the gray wire, which is connected to pin number 7, to the first button, or to the other side of the first button, followed by this wire, which is connected to pin 8, followed by blue, connected to pin 11, green, connected to pin number 12, and yellow, which is connected to pin number 15 or A0. So let me first set up the variables. For button 1, I'll assign number 7. I'll just copy the same line and make changes. Button 2, button 3, button 4, button 5, button 8, pin 8, 11, 12, 14, also known as A0. Alright, and then I'll set the pin mode of every button to input pull up. find out the status of every pin connected to the buttons. Since they are all set as input pull-up, all of them should be high. So to do that, I'm going to enable the serial communications port. Send messages or print messages that we can monitor. So I'm going to send or print the status of the first button. So digital read button 1. Paste and then copy, same line. Button 3, button 4, and button 5. Let's upload to the robot. I'll check first the setting. I'll connect this to the robot. I will upload and I'll open the serial monitor. You can see all pins are high. This is pin 7, followed by 8, third one is 11, fourth is 12, and the fifth is 14 or A0. So since all pins or all buttons are also connected to ground, pressing each button will change the status of the pins from high to low. Let us check. First button. Just make it smaller. Second button. Third, fourth, fifth. So this should be our expectation. All pins should be high since they are set as input pull-up, and pressing every button should set it low. If the buttons do not behave like that, then you have to check what is causing the problem, or do not try and use the pin in the meantime. So now that we have tested and we are sure that all pins are okay to be used as buttons, we can now proceed to further coding. So I may want to save this. I'll save it as use the template. Insert this. Here. Okay. And then I'm going to insert that here. Then continuing this. In the meantime, and I'm going to probably use this temporarily for demonstration purposes. I'll just put that here. Okay, so I have the template plus the buttons all set as input pull up, and the next thing to do is to make things easier. So I'll create a function that will check whether or not the button is currently pressed. I'm going to name the function pressed, and it will return a value which is integer, and pressed will require some information. It needs to know the pin number where the button is connected to. So byte button okay. So the way press will be used is like this. So if let's say if the first button is pressed, hold on. If the first button is pressed, I will display a message. So I will call pressed and ask pressed if button 1 is pressed. Okay, so button 1, take note that button 1 contains 7. So 7 will be passed to button. Okay, this is 7, becomes 7. If I put here button 2, since button 2 contains 8, this also becomes 8. So whatever information I put here will be passed to the function pressed. Let's start with 1. So I'll just put some space. This is the loop function. So if pressed will check if digital read. So let's check the status of the button. If it's currently equal to low or 0, then it is pressed. Return 1 to confirm that that button is pressed. Otherwise, return 0. So are my brackets okay? So this is start, and this is the else clause. Okay. So here, if pressed says 1, then okay, serial dot print you pressed 1. Okay, already pressed button 1. Let's check if this will work. Upload. I'll open again the serial monitor. Done uploading, so I'll check. I'll press the first button. And there are many, simply because the execution of the program or the loop, the entire loop, is done in microseconds. So it happens very fast. So what I'll do is I'm going to set a delay so that my finger leaving the button will not count. So I'll put the delay here. And then upload. Let's check if this will work. Okay, I'll check. Okay. There's actually a better way of doing this. However, that will be a different topic. But let me just continue the demonstration, and I'll include the other buttons. So this will be 2, 3, 4, 5, and then I'm going to upload. Oops, I forgot to change this. Check. So I'll press the first button, second, third, fourth, fifth. Again, 1, 2, 3, 4, 5. So everything worked. I'll probably change this. Instead of displaying a message, I'll make the robot do something. If the first button is pressed, I'll make the left motor turn. Set left motor. Before I do that, I'll lift the robot up. And connect the battery. It's just for demonstration purposes. I will use set left motor. Turn the left motor. Left motor, 40%, and then delay, say 2 seconds, and then stop. This will be for right. This is for no, I'll change this to left, but I'll make it move in reverse by making it negative 40%, 40% of 9 volts, which is 3.6 volts. Making it negative will make it move the other way. This is right. Negative to move the other way, and then this one will, the last one will make the both motors move forward, just for demonstration purposes. 40%, wait for 2 seconds before stopping, and let's check, upload. One, they should make the left motor move or turn forward for 2 seconds and stop. Pressing number 2 will make the left motor turn the other way for 2 seconds and stop. The other one, so I'll press 3, forward 2 seconds, stop. Button number 4, reverse 2 seconds, stop. And this will make both motors move forward for 2 seconds and then stop. One last demo. Let's say I'll make the robot beep once if the first button is pressed, say 255 maximum for 50 milliseconds, and then twice if the second button is pressed, thrice, and then of course 4 times, and 5 times if the last one is pressed. Let's check. Again, 1, 2, oops, I may need to put a delay here for 10 milliseconds. Again, check. 1, oops, 1, 2, 3, 4, 5. There. So our buttons work and everything is okay and everything is behaving properly. All right. You can mount the buttons on top. We can replace the cover. And mount this on top. And use the buttons temporarily for whatever purpose it may serve us. Okay. However, in cases where you don't have the materials, such as the breadboard, buttons, and additional wires, we can do the following instead. So I'll remove the cover again. What you can do is this. The remaining wires from the original box, there should be 4, but in my example I'll make use of 6. One, 2, 3, 4, 5, and 6. Okay, so I'll connect this to ground, but before that I need to insert a pin on one end of the wire. The pin will do. Make sure it will not fall. One end to ground. Make sure that the robot is not powered when you do this. And then I'll connect this to pin 7 and 8. Seven and 8. So orange 7, yellow is 8. And this is 11 followed by 12 and green for 14. And I can just put it back. Finally, the button press. I'll plug in power. And remember, when you press a button, you are basically just connecting the two sides. So we are going to simulate a button press by connecting the pin to ground manually. So this is button 1. So I'll just connect ground or connect ground to pin 1. So this is metal, that is metal. So connecting the two will allow current to flow to ground, changing the status of the pin from high to low. So I'll make it quick. Okay, 1. Okay. This one. So we should hear 2 beeps. This one. Will give us 3 beeps. This one is 4. And this one, 5. So temporarily, we can simulate button press using wires. So this is button 1, button 2, button 3, 4, and 5. And in case you don't have wires left, we can do this instead. Only one wire is left. What you can do is connect this to ground. Connect this directly to the pin. So I'll just let it touch pin number 7. It will be a bit hard, but this is what you do if you don't have, oops, if you don't have much, if you don't have the materials that you need. So I'll connect these two, but you have to be very careful. If you intend to make this connect to pin number 7, make sure it only connects to pin number 7. So I'll double check. It's connected to ground. I'll connect it to pin 7. Okay, I'll make it quick. Not quick enough. I'll connect it to pin 8. I'll connect it this time to pin number 11, so we should get 3. We should get 4. And for the 5th pin, A0 or 14, we should get 5. There. So that is how to simulate a button press using a single wire. But this is just for temporary solution only. Again, just a temporary solution if you don't have the materials. Again, be very careful in connecting the wires, as you might damage your robot. Make sure you know what you're doing, and you have to be very careful when you do this.